Hi guys, welcome to Chapter 6 review. I'm going to just go ahead and do a video for the answers. So for number 1, they want us to draw a diagram and then mark the corresponding parts if triangle HGI is corresponding to triangle LQP. So I'm going to go ahead and I'm going to start with my angles. I have H is congruent to L, G is congruent to Q, and I is congruent to P. Then I'll have HG is congruent to LQ, GI is congruent to QP, and LP and HI are congruent. So that's number 1. Number 2, they wanted us to name the corresponding parts for number 2. So I'm going to say that angle R is corresponding to angle X. Angle S is congruent to angle Y. Angle T is congruent to angle Z. And then for my sides, I have RS and XY are corresponding. So we know that RS is congruent to XY. And then we have ST and YZ, and then TR and ZX. And we can see that, I have to move that back a little bit, that these two have 1 tick mark, these two have 3, and then these two have 2 tick marks. Okay, let's see, sorry about that. Okay, number 3. If the measure of angle 3 is 115, what is the measure of angle 6? Well, I see that these are alternate interior angles. They're alternate because they're on different sides of this transversal line here. They're interior because they're in between the parallel lines. So 3 and 6 are going to be congruent. They will be equal. So 115 is my answer. Angle 3 and angle 7. I see that angle 3 and angle 7 are corresponding angles. They're both on the bottom left, so they're going to be equal as well. It's 115. If 3 is 115, what is 2? These are vertical angles, and we know that vertical angles are also congruent. So once again, we have 115. So 3, we have alternate interior angles, corresponding angles, and vertical angles, and those are all congruent. Okay, so down here we have that the measure of angle 8 is 62 degrees. What is the measure of angle 1? Well, these are alternate exterior angles, so I know that these are going to be equal. So measure of angle 1 is 62 degrees. Okay, 6 and 5. So if 6 is 120 degrees, we have 6 and 5. This is a linear pair here. What I know about a linear pair is that when they're added up, they're 180 degrees. So 180 minus 120 for angle 6 leaves me with 60 degrees. So angle 5 is going to be 60 degrees. Okay, and then I have angles. Here's angle 2 and here's angle 5. If 2 is 130, what's angle 5? Well, they're not they're alternate, but they're not both interior and they're not both exterior. So I'm going to have to try something different. I see here that 1 and 2 are a linear pair and that 1 and 5 are corresponding. So if I figure out what 1 is, I'll also know what 5 is. So 1 plus 2 is 130 degrees. So 180 degrees minus 130 equals 50 degrees. And so if angle 1 is 50 degrees and angle 5 is also 50 degrees. All right, so that's 1 through 8. Number 9, we're given a proof. So we're given that lines L and M are parallel and P is parallel to Q, and we have to prove that 12 and 5 are congruent angles. Okay, so the first thing I'm going to do is I'm going to write out my given that L is parallel to N and P is parallel to Q. And that is given. My second step is that, let's see, I need to figure out, well, I can use angle 13 because they're alternate interior and corresponding. Okay, so since these two lines are parallel over here, I can do alternate interior angles. So I'll go ahead and do that. Angle 12 is congruent to angle 13. And they say it's the parallel postulate as their answer. And the reason is alternate interior angles are congruent. Because those two lines are parallel. There we go. Okay. And then we can say that angle 13 is congruent to angle 5 by the corresponding angle theorem, which says that corresponding angles are congruent. All right, so now I can say that 12 is congruent to 5 by the transition or transitive property. Because I have 12 is congruent to 13, 13 is congruent to 5, then I'll just go angle 5 is congruent to angle 12, and that would be my transitive property. Of congruent angles. Okay, so then that's proved. That's proven. Okay. Number 10, we have that P and Q are parallel, that angle 2 is congruent to angle 14, and we need to prove that these two lines here are parallel. So I'm going to do this. 1, P is parallel to Q. Angle 2 is congruent to angle 14. So angle 2 is congruent to angle 14. Okay. So what do I see here? I'm going to look. I see that if these two are parallel, I can do corresponding angles here, and then I can do corresponding angles here. Because I can't, there's no really connection between this one and this one, so I have to take that middle step. And I see that 6 is in a corresponding place with 2 and with 14. So I can say that angle 14 is congruent to angle 6. Oops, I didn't write given right there. Sorry, guys. Angle 14 is congruent to angle 6. And that is through the corresponding angle theorem. And then I can say that angle 2 is congruent to angle 6 using the transitive property, because if 2 and 14 are congruent and 14 is congruent to 16, then 2 has to be congruent to 6 as well. So transitive property of congruent angles. I'm sorry. Number 4 is going to be that L is congruent or parallel to N by the corresponding angle theorem again. Because the corresponding angle theorem tells us that if we have two parallel lines and their corresponding angles are congruent, but also if we have two congruent corresponding angles, then these have to be parallel lines. Okay? Number 11. Triangle or angle ABC is congruent to XYZ. So we have ABC is congruent to XYZ. And we have ACB is congruent to XZY. And that BC is congruent to YZ, and we have to prove that triangle ABC is congruent to triangle XYZ. So my first thing is going to be to write down everything that's given. and I marked everything on my diagram over here, and I see that I already have angle, side, angle. So basically my proof is done. I just have to write out that triangle ABC is congruent to triangle XYZ, and that's, sorry, I did that again, proven by angle, side, angle. And that's the whole proof for number 11. That one was a nice and easy one. All right, number 12. We have the circle, these two chords, and this. So we have R, S, T, U, V. T is the midpoint of RV, and US. So if it's the midpoint, then we know that these are going to be congruent. All right. I'm actually going to do it this way, so that this part is congruent to this, and then this is congruent to this. All right. So for number 1, I have T is the midpoint of RV and US. Oops, yes, I have to do this over here because I wasn't watching the paper. I was watching the screen as I was doing this. And that's given. So if T is the midpoint, then I know that RT is going to be, well, is equal to TJ, and UT is equal to TS. It's going to give us definition of midpoint. I'm going to move this over here. And then I can say that, RT is congruent. Oh, that's a V, not a J. Sorry. To TV. And UT is congruent to TS. 3. That's going to be the definition of congruent segments, because if two segments are equal, then we know that they are congruent. Okay? So I'm looking at this, and I need to prove that this triangle here is congruent to this triangle. I already have two sides, so I'm going to look for an angle. When I'm looking at this, I see that I have vertical angles here, and vertical angles are congruent. So I'm just going to go ahead and just go to that step. So number 4 is angle RTS is congruent to angle VTU. And that's going to be the vertical angle theorem, which says that vertical angles are congruent. I see now that I have side angle side, side angle side. So triangle RST is congruent to triangle VUT, and we proved that by proving side angle side. Okay, let me back that up a little bit, and you guys can copy that. If you guys need to copy these down, if you have mistakes, you can pause the video and